Hi everyone, I'm really excited to interview Daniel Bolojan, founder of Nonstandardstudio. He is computational designer, lecturer, researcher, and ML enthusiast. Daniel is currently assistant professor focusing on the application of computational design and deep learning strategies in architecture design process. In this interview, you will get to know Daniel's journey, his professional works, thoughts on application of AI in architecture, along with advice to young professionals and students to get started. So I have attended Daniel's digital future workshops later, and it was quite useful. And he has given some amazing lectures on digital futures platform. So without much ado, let's jump into the interview.
Hi,
Hi,
everyone.
Daniel.
Hi. Thank you for the invitation. It's really great being here.
Yeah. Can you tell us about your background, where you grew up, and why you chose to study architecture?
All right. So that's a long story, but I'll go through it. So originally, I grew up in Romania, which is in Eastern Europe, and I grew up in a city called Oradea, which is on the western part of Romania. It's a quite small city, like 240,000 inhabitants, and the city is quite close to the border with Hungary, like something like 20 minutes drive, something like that. Yeah, the reason why I'm mentioning that is because I think that had a great impact on me, because it was easy for me to have access to the west part of Europe, let's say, from there. So my interest in architecture, yeah, like I said, it's a long story. I think I was always excited about architecture. I was born in this city that was very dominated by Secession and eclectic and Art Nouveau kind of architecture that I always enjoyed, walking through on the streets or in the city center and just enjoy that architecture. And beside that, I really remember that when I was quite young, actually, something like 12, 30 years old, my parents designed our first house. So I was, I think, very fascinated to look at the floor plans and sections of that house. Right now, of course, when I look back, it's like, it's a bad design. But I think when I was super young, I was like very fascinated about that, trying to imagine looking at floor plan sections and, facades and try to imagine how our future house will look like. And then I think also later when I started to visit my grandparents, I was always like playing with clay and trying to build up these kind of foundations and then walls and think about design and so on. Yeah. So I don't know, maybe this had an impact on me or not, like this kind of the fact that I was born in that city with that kind of architecture. But I think I was always, yeah, personally, I think I was always excited about architecture, about buildings. In middle school, for example, I was actually quite good at drawing. Yeah, so I wasn't a student for sure in middle school. I was an A student. I wasn't either a C student. I was not failing, but I was not like, performing that well. But all these kind of topics that dealt with being creative and drawing and stuff like that, I was actually performing very well. Yeah, I had quite big problems with topics where you have to learn something, just for the sake of learning it. So I think for me was always, if I don't have fun with it, I'm not going to do it. And I think this attitude in a way is also something that I have now. It's like, if I'm not enjoying something, I'm not going to learn it. And it's not that I'm not going to learn it as a decision not to learn it, but my brain is not going to compute. It's just not going to stick. Yeah. So afterwards, after middle school, of course, I went on to studying in high school. And in high school, it was great that they had an architectural section. So we had the art high school that had also architecture section. So I was really, a privilege, let's say, to start to be introduced to ideas of architecture early on, like high school already. And I remember that also in the library of the high school, we had a lot of magazines. They were not now the most famous ones, but we had some magazines there that were showing some architecture from outside of Romania. And that was where I started to be introduced to the work of Zaha, for example, and also Karim Rashid. And I'm saying also Karim Rashid because the architecture class in art high school, or at least in that art high school, it had this kind of mixture between industrial design students and architecture students. Yeah. So a lot of my peers, they were studying industrial design. So they were designing objects and they were designing cars and so on. Yeah. So for sure, I was in a way influenced, yeah, to look at designers, not only at architects, So that's why I'm saying, also Karim Rashid, he was a very like influential person also of Zaha did, yeah. So I think from the very beginning, like my very first project in high school was very daring. It was very, I was not actually drawing just cubes or something. I was really trying to do something interesting, yeah, with architecture. And it was great that we had some professors that they were part, let's say, architects, part sort of artists, let's say. So that gave us a bit more freedom, to it wasn't like, that architecture is like this and you have to draw like floor plans and sections and stuff like that. It was mostly, conceptually like from a formal in a way perspective, like how you sculpt something and so on. Yeah. So I think that was an amazing thing. Yeah. So like I said, yeah, at the beginning, yeah, once I started to go into art high school, that was my thing. Yeah. I really loved what I was doing. So suddenly also my performance in other subjects started to improve. Yeah. And slowly then I also started to participate in regional and national Olympics in architecture, and also got a honorable mention and also a first prize nationally in architecture Olympics. Yeah. So I'll just leave it here because I think there are many other things to say, but that's my beginning. Yeah. And after that, I started like, of course, studying at university and all those things.
Yeah, it's quite interesting because like we get to see like the earlier exposure of architecture like made you curious to experiment and have
Yes,
fun
I think
with.
yes, I think that's amazing. Like that's extremely important. Like to get to be exposed at the early age to this kind of quality design like Zaha and also Karim Rashid. I think that was an amazing thing. Because I think this is something that really helps you cultivate a sort of sense of architecture and style and so on.
I see. And I know you mentioned about your high school and undergraduate architecture experience, but are there any highlights from your undergrad, master's, or PhD study which shaped your design philosophy?
Okay, so this is also a long discussion, and for me, you'll see that during this talk that we have, there is a clear progression. Like I started with things, and then I not changed my mind, but suddenly I understood like how to do things better, and then change and improve, and then again you figure out something else and you improve more and so on. Yeah, and I think this is something that could be very amazing, yeah, for everyone to think of and maybe experience this kind of process, like constantly in a way iterating and constantly in a way improving your skills and your understanding and so on. Yeah, I think that's an amazing thing that can benefit anyone. So design philosophy change. Okay, so I think it changed quite a lot. Like from early on, like I said at the beginning, I discovered the work of Zaha and Karim Rashid in high school. Yeah, and back then their work had a very big impact on my way of thinking about architecture. And then when I was a junior years, I already decided like where I want to go to university. And I remember that I really wanted to go at the best university that we had in Romania, which was the university in Bucharest. So in the first year in Bucharest, unfortunately, not unfortunately, but what happened is that, there are certain projects that you have in the first years. And somehow I started to be drawn more towards Tadao Ando kind of architecture, which is very modernist, very, orthogonal in a way. But still, I think why I'm mentioning this is because also with Tadao Ando, I think there were a few sensibilities that I learned, yeah, about. And in the first semesters, yeah, I was actually doing great when it comes to this kind of very minimalist in a way, Tadao Ando kind of architecture. But then later in the second year, I managed to switch the studio to a professor where he was a bit more open-minded. Yeah, it was a professor that was very inspired by Daniel Libeskind, for example. So there, I started again to go back to these kind of influences of Zaha, of Rashid, of Libeskind, and Mirales and other kind of great architects. Yeah. But then during that year, I recall that Neil Leach gave a lecture at our school. And in his presentation, he started to show some very great work from Columbia University and also Dessau and other several prestigious schools, yeah, that he was teaching at. And I was just stunned by the kind of processes, the kind of projects that the students were developing in those schools. And soon I realized, that I mean that lecture for me was an eye opener. I soon realized that I have to switch tracks. Yeah, if I really want to be like super progressive architect, and if I want to create this kind of like amazing architecture and be truly innovative, I have to switch to this kind of more traditional way of doing architecture to a more progressive way of doing architecture, where you start to design processes instead of just sketches, floor plans, and stuff like that. Yeah. So yeah, Neil, I ended up being a good friend with Neil, and even today, like we are great friends, and I think he's an amazing friend to have. So yeah, I can say that Neil had a very important point in my career where I had that kind of switch, at least in terms of imagining what I can do. Yeah, because until then, probably it was always like, Zaha, it's amazing, Rashid, it's amazing, Libeskind, it's amazing, but they are just architects. Yeah, and I think it wasn't personal enough for me. But then when I saw in a way students engaging in those kind of processes, it became very personal and very relatable, let's say. Yeah, and suddenly it was easy for me to relate and to be like, I want to do also these kind of things. So what happened after that lecture in the same year, I had a friend that studied in London as an Erasmus student, and he had a colleague that studied in the same year at the Angewandte Kunst, which is the school where Zaha Hadid, Greg Lynn, and Wolf Briggs were teaching. Yeah. And through that friend, I got introduced to that school. Yeah, I heard about the Angewandte. So of course, once I heard about that school and I heard that Wolf Briggs and Greg Lynn and Zadid are teaching there, I was like, I want to study with these people. Yeah, I want to study with Zaha, because yeah, Zaha was like I said, from early, like since high school, I really liked her work. Yeah. So that friend of mine put me in contact with his colleague, and I got to be introduced, yeah, to how things are running in the Angewandte and all those kind of things, yeah, like inside the staff information, like about how studios are structured, how the projects are structured, and so on. And I was just amazed. Yeah, I was just amazed of this kind of idea of vertical studios, where it doesn't matter if you are first semester or the last semester, you all have the same project, and somehow through that kind of format, you're forced in a way to learn. Yeah, and you're forced, not only forced, but also you're in a way given the chance to deal at that kind of level. Yeah, because they are not considering you like, yeah, you are just a first semester, you don't know how to do these kind of buildings. Yeah, they were like treating everyone the same, and they were saying, you are first semester, but you should be capable also to design a museum, for example. Yeah, like a one that it's in fifth semester or something. Yeah, and the amazing thing there was that it was extremely open in a way exchange of knowledge from lower levels to upper levels. Yeah, so the ones in higher levels, let's say the fifth semester, of course they'll show you by the, or you'll learn by the way that you see what they are doing. Yeah, you see what they are doing and you start to learn in a way. And and the other way around, the students from upper semesters, they will look at freshmen and will see in a way innovative ways of looking at things. Yeah, like fresh eyes. And suddenly you, as a freshman, in a way, you're like, suddenly you propose an idea that may be one that is there for some time, never thought of. Yeah, and I think this kind of exchange was amazing. Yeah, so of course I decided in a way, yes, I want to go there. So after 2 years almost of trying to get there, I managed to get there, and I got accepted in Hadid Studio. So Zaha and Patrick, because when I got accepted, also Zaha Hadid was teaching there, and also Patrick. I think they had a tremendous impact on my understanding of architecture, and I cannot emphasize more how big of an impact they had. Yeah, during that studio time, I had for sure a 180-degree turn, where I started to understand architecture as a system. I started to understand architecture as a sort of self-organized system. Yeah, Another like very important book that really had a great impact on me was Encoding Architecture by Liz Werner. And there was a particular, in a way, paragraph that really changed the way that I started to look at architecture and also the role of architect. So it was saying something like the architect is no longer, sorry, the architect is no longer an organizer of matter and space, but a designer of systems with multi-layered components and complex relationships. Yeah. So this was like a clear paragraph for me that start to put things in place and help me understand in a way this idea of architecture as a system. Yeah. So personally, like I was always somehow inspired or always interested in intelligence. Yeah. And probably you'll see maybe that's one of the reasons why right now I'm into AI space. I was always interested in intelligence. Yeah. But it was just during those years in Studio Hadid where I actually discovered how to encode intelligence in design and how to properly think of encoding and those kind of topics. Yeah. So soon after I joined, yeah, I was very fascinated with self-organized systems, with swarm systems, and most of my work that I done in Studio Hadid, this kind of deployment of self-organized systems, yeah, different types of, either swarms or other relaxation, algorithms, principles of self-organization, yeah. So the reason why swarm intelligence, why I wanted to go with that, I think I found the that model as being a very good geometrical model that allowed me very easily to encode intelligence, yeah, from structural, environmental, and also design level intention. Usually what happens with other geometrical systems is that it's very hard in a way to encode certain intelligence because of the structure of the system. Yeah, if I say that I work with a mesh, some with a mesh, then okay, what kind of intelligence I can encode there? I can encode relaxation maybe and some morphodynamic, morphodynamic in a way kind of design where I just have external factors influencing somehow the shape of the mesh, but I cannot really encode like the mesh itself somehow to be intelligent, yeah, to have certain behaviors and so on, yeah. So I think that's why I went into that kind of direction with swarm systems. Of course, now later, my interest in intelligence found its way in my work with Coupion Blau, which I joined as a computational design specialist, and I was developing a lot of like computational design tools and also AI networks of there. And then, of course, afterwards, also in my research that I did with Patrick Schumacher called parametric-based parametric semiology. And then also later in my teaching lab, when I started to teach also at Innsbruck, I was invited to teach at Innsbruck by Christina Schiniger and Stefan Lutzinger. So over there during those studios, I started to have these kinds of studios that dealt with agent-based systems. And even in 2016, end of 2016, we started to look at creative AIs and how you can couple this kind of creative AIs with agent-based systems. So yeah, it's a brief thing, but you see there are a lot of points. I mean, that's why for me it's hard to say a specific point. There are a lot of points in my, let's say, life, as an architect, a lot of points that were turning points for me and crucial points where I switched from old way of thinking to a new way and then new way and so on. Yeah, this kind of constant iteration.
I see. Sounds like even like the philosophy is very evolutionary, where like with time.
Yeah, I'm a true believer in self-organization for sure.
I see. Yeah, but like there were some many good points about swarm intelligence, creative AI, intelligence-based system, and hopefully we'll able to dive deeper in your professional work section. And I see like I see your professional work. You're also doing PhD. You conduct workshops. So like, how do you manage your day? Like, can you talk about how does a day of your life look like?
Yeah, so my life is a bit crazy. Probably I will not recommend it to everyone. So usually I go to sleep around 3:40, 4 o'clock in the morning, and I wake up around 8:30, something like that. So it's a very intense, let's say, work day. Usually I have my mornings, I kind of reserve them mostly for meetings. So all the time, if I have some meetings, I prefer to have them in the morning. And this is also because I'm a consultant at the moment. Currently, I'm an assistant professor in Miami, but I'm also still collaborating, and I'm a consultant with Copia Blau, where I'm working on developing the Dipima Blau network. Yeah. So because of that reason, in a way, I have to have my meetings in the morning. Yeah, because if I want to meet with the office, I have to be available when it's also fine for them. Yeah. So 9 o'clock, for example, here is 3 o'clock p.m. there. So then, most of the mornings are going to be towards the end of the day there. So I prefer then to have my meetings in the morning. If I don't have if I don't have meetings in the morning with the office or research collaboration or other kind of meetings that I have, usually what I do is I have scheduled papers that I want to read. Yeah, there are certain papers that I want to read, and this is something that I discovered over going through it. Yeah, I discovered like this. Usually, I prefer papers over tutorials. Let's say, yeah, because I find in a way that the actual true information and the deepest kind of information that you can learn is in research papers, not necessarily in tutorials. I think tutorials and tutorial, they can help you in a way get you started, but that should be just that. Yeah, you should not expect in a way from tutorials to exponentially, let's say, increase your knowledge or something. Yeah, if you want to do that, then you have to go into actually reading papers, a lot of papers. Yeah, and try to understand different approaches, different problems that they are trying to solve, and why they are trying to solve these problems, and so on. Yeah. So that's that. Then around noon, usually I have my classes, yeah, that I'm teaching, design studio or other computational design classes. I'm teaching usually, yeah, the schedule is almost around noon, something like from 12 o'clock till 4 o'clock, something like that. And what I do afterwards, right after I finish the classes, usually I just go for a walk, or I go for a drive along the ocean drive in a way. So I just to relax, to enjoy the sun, because I'm living here in Miami. It's like always sunny, so I better take advantage of it. Yeah, so that's what I'm doing right after that. And once I get home, like late afternoon, let's say, usually I start working on research papers, writing research papers or grant proposals. We are working on trying to build up a AI lab here at the school where I'm teaching. So there's a lot of work that is put into that. And then after 10 o'clock p.m., usually I switch to writing code. And usually all my development in writing code happens during that period, like 10 o'clock p.m. till 3, 4 o'clock in the morning. Yeah, so writing code on different kind of projects that I'm working with. Yeah, that could be like Gaudi and neural networks project that I'm working with, the DPO Blau network, or other, in a way, other codes that needs to be written for research projects that I'm working on. So that's mostly my day. Yeah? And then the cycle repeats, and next day comes in, and there you go again.
Yeah, like sounds quite busy.
Yeah.
And like just before we move on, I'm curious, like when you mentioned research papers, are those mostly focused on architecture technology or also on like statics, algorithms, even in AI? Like what are different domains are you referring?
So yeah, related for sure to different interests that I have in research. So for sure, there are a lot of computer science papers, because personally, I'm not just a theoretical, or let's say, researcher of AI. I'm also trying to create actually my own networks. Yeah, and also the PMO Blau network is the case. Yeah, so I literally created the network. Of course, it draws inspiration from a lot of other models that are out there, but it's our network. Yeah, it's something new. So to get there, then you need to really understand a lot of things about neural networks, which is not easy. Yeah, and especially it's not easy because I'm coming from a architecture background, not from a computer science background. So then it's very imperative for me to really go over that literature and really understand the developments in computer science. Yeah, like research papers that you have there. Then, of course, my research is also focused on aspects of creativity and creativity in architecture design. So then, of course, you have to start to approach aspects of what creativity is, yeah. And then once you get there, yeah, you start to talk about the ideas of neuroscience, because okay, how the brain works, how we are creative as humans, you know. So there are then different kind of disciplines, yeah, that you have to span, and you have to sample through, you know, a lot of like papers and try to understand in a way like these are relevant for the research that I'm doing, and these are relevant, yeah. And you have to somehow cover all this at the same time, yeah. It's a daunting, let's say, task, but I think it's important, yeah. It's important if you really want to be able to output something that is really making an impact in the end in the field. So yeah, those are mostly papers of computer science, neuroscience, sometimes creativity, and other kind of things.
I see. Mm, what are some challenges faced in your career and how did you resolve it?
So I think some challenges that I had. I started working with Grasshopper, for example, 6 months after it was launched. So it was very challenging, yeah, back then. It was very, very challenging because there were limited resources. So I really had to, you know, like myself figure out things, you know, something that today will take you like 20 minutes search on Google. It took me then, you know, days, if not weeks of figuring things out. Yeah. And I think that was a huge challenge for me. Like, you know, I was I was trying to create the kind of designs that were done in Studio Audit with modeling. I was trying to do those kind of things with coding, and that was super challenging. But in the same time, I think it was a necessary, in a way, thing that forced me and helped me get where I am. Yeah, because this kind of like impossible milestones that you're putting for yourself, yeah, that forces you in a way to really advance a lot, yeah. Because otherwise, if I were to be like just complacent and just say, you know, I'm just going to do, you know, modeling, then you just end up with super good designer skills in modeling, and that's all, yeah. But because I started to force myself and say, you know, I want to use computational design, I want to use coding, I want to use these kind of methods, and reach that kind of level maybe of complexity, that pushed me further ahead, I think. But those were super challenging things, yeah. So always, if you start something new and there are not many people doing that, it's extremely challenging, yeah. So it happened to me the same, and I'm going to also maybe go over this just in a moment. I had to switch at one point from pure or normal type of coding to CUDA programming because of computational limitations. And suddenly those kind of things are extremely challenging, because CUDA, for example, even in computer science, it just came out. Yeah, it was like quite recent. Yeah, like this kind of parallel programming and using the GPU as a processing unit. So those things were extremely challenging, and so I ended up in a way having to go through a lot of papers or articles, or trying to figure out things. Yeah, trying to debug without having whom to ask. You know, because there were not many people dealing with those kind of issues. So I think these were some of my challenges. I don't think like today probably those challenges will not exist. I think today we live in a overabundant, in a way, or abundance of resources. Like you can go online these days and learn anything you want. I mean, unless now it's rocket science or something that is super advanced, you know. Those kind of things, probably they still don't have that many resources. But when it comes to computational design and architecture, I think there are plenty of resources at the moment.
I see. Like, and I like the fact that like you were quite early adopters in various new technology and might have been like most of the things were like self-taught because there were no readily available courses and modules for it. And and when you were saying it might like take days for the same thing one can do and find like, but also like there is a different joy of satisfaction when like suddenly like after a lot of debugging your code works and you found a new way of doing it.
Yeah, that's true. You feel great when, you know, like that kind of dopamine hit, like amazing, I did it, you know. After, and I think you live through these kind of moments. And I think once I had this kind of breakthrough with AI, for example, a breakthrough with some networks that I'm developing. It was during a holiday, actually. And, everyone was, having fun. It's a holiday, like enjoying life. And I was trying to debug and fix things, and suddenly it happened. And after that, I was like, amazing. Now I can go out and enjoy life, because it really happened. I managed to break through this. So yeah, for sure. Yeah.
I see. And yeah, a little bit on parallel computing. Like most of my exposure in that area is like using shaders, and like definitely it's more computationally efficient to use GPU compared to CPU. Like, can you throw some light on how you're translating that into design?
Okay, so maybe we can go through. I'm going to go over that if in the following questions, and I can give more details there, perhaps, yeah, about GPU, because it's very connected with this kind of progression. Yeah, like I was trying to design in a certain way, and that led me to a certain tools that I started to use, yeah, to be able to design in that way. And also GPU, then I was also using at one point shaders for sure, but still you have limitations, because it's not only about the hard part is not only about displaying things, it's also about calculating. And especially if you work with self-organized systems, you have a lot of proximity checks that are not really that computationally friendly, let's say. So then you have to somehow send those kind of calculations to a GPU. So you use then all the thousand of CUDA cores. Yeah, and I had the chance, yeah, to have like some strong graphic cards back then. I had about 4,500, I think, CUDA cores in total, which was amazing. Yeah, I was able to really calculate quite a lot of things. But yeah, briefly saying, yeah.
I see. And the last question in this section is, what was the defining moment when you realized that, oh God, machine learning could be a game changer in AEC?
Okay, so yeah, so here again, I have to go through a sort of story, yeah, because personally, I cannot really say that there was a precise moment. Yeah, I think it wasn't a moment that I can precisely identify, but because my work is mostly a sort of progression. Yeah, I'm keep on trying to solve certain things. I'm interested in intelligence, how to bring design intention in these kind of systems, and how to learn that kind of design intention. So because of that, in a way, I'm always addressing a problem that I have in the process, and because of that, I bring a new technology or something else. Yeah. So, like I said, my interest in intelligence in design carried me, let's say, through multiple computational design techniques. Yeah. Initially, when I started working with self-organized systems, I was pretty much working with parametric design, like Grasshopper. Yeah. And soon after that, of course, you start to hit limitations regarding the complexity of the simulation, the computing power, the number of agents you can use, which is extremely crucial, yeah, for emergent phenomena to happen, yeah. And of course, there are many other limitations when it comes to Grasshopper, as you don't have full access to the code. Yeah, you just have these kind of components that are encoded, and you don't have access to the source code in a way. Yeah, so it's very then hard to deal with that. So then slowly I started to go into Mel scripting. And Mel scripting is Maya scripting language, let's say, where you can write code into Maya. But also there, I think there were many limitations with the scripting language itself. And I was not really happy about it, yeah, when I worked with that. So afterwards, of course, I was pushed towards like you have to learn a language that is not dependent on a specific platform, like Maya or Rhino or Grasshopper. And so I started to look into Java. So Java, of course, opened a lot of doors for me for creating explorations, allowed for me to develop strategies for encoding architectural intentions in agent systems that previously were not possible. And most often the scale of those projects that I was able to work with was, this kind of strategies that were developed at a sort of pavilion scale, yeah. And most of the geometrical, in a way, strategies that I were able to develop there were dealing with strands or lines, bundles, and stuff like that, yeah, or points and so on, yeah. But the problem with that is that architecture is not only points and lines, yeah. Architecture is also solids, surfaces, and so on, yeah. So adding that kind of more complex geometries while also increasing the scale then, because I didn't want to just stay at the pavilion scale, was something very, very challenging then for Java only applications, yeah, for Java only agent-based systems. So I started to look into creative ways how you can write your scripts in a very clean way so that they are very lean and very efficient computationally. So of course, I started to look at this kind of shaders. I started to look at different algorithms like octrees and other kind of proximity calculation algorithms just to drive down in a way the cost of computation. Yeah. But even there's that much that you can do. Yeah. Certain things you cannot go lower than that. Yeah. And most of the time I was able to run these kind of simulations that had about 2000 agents, let's say. But if you really want to have like big scale in a way projects and also have this kind of emergent phenomenon to happen, you need to have more than 2000. Probably you need to have 10,000, 100,000, a million in a way agents to be able to really have this kind of emergent phenomenon happening. Yeah. So something like that, then it was very challenging. Even if you apply shaders, even if you work with very optimized algorithms, yeah, it's still very challenging, yeah, because you have proximity calculations that are very expensive still. So then I started to look into CUDA. So I think CUDA was very recent then. It was something like 1 year or 1.5 years. The CUDA idea came out, and also GPUs, they start to have CUDA cores. So I just jumped on the bandwagon. Yeah, I just jumped on it and I was like, let's see, can I use then the distributed power of GPUs to help me solve this problem. Yeah. And then another problem was also a conceptual problem, because we are saying that agent-based systems are running simultaneously in a way, or it's a simultaneous algorithm. Yeah, because one agent from here interacts in the same time another agent here interacts. Yeah. But what's happening usually when you run the code on a computer, you're not really doing that. You're actually going through a sequential process, because the processor, the CPU, is processing things in a sequential manner, not in a parallel manner. So then it doesn't matter if you say that the agent-based system is parallel, is not really parallel in the sense of how it's playing out, because the CPU is reading one, and then the second one, and then the second one. Yeah. So it's not reading all the interactions at once. Yeah. So then to solve these two issues, yeah, CUDA and JCUDA in special. JCUDA is the wrapper for CUDA for Java. Yeah. So JCUDA and CUDA made perfect sense for me, yeah, because it solved and also this kind of computational demand that I needed for this kind of systems. And also it solved this kind of conceptual problem, yeah, that you're making an argument for this kind of distributed in a way parallel kind of system, which is agent-based system, while in fact you're processing the system in a sequential manner, you know. So I think this kind of things, then of course I was interested in encoding not only large populations of agents, but also start to bring in topics of structure. Yeah, can you have an agent-based system that is aware of structural constraints? Can you have an agent-based system that is aware of environmental constraints and so on? Yeah. So once you start to bring all that information, of course you need compute power. Otherwise, you're going to wait, like, you know, for a frame in a simulation, you're going to wait 20 minutes or something, you know. So that's not something feasible then to work with. Yeah. So of course, for me, it was always this kind of like challenges, bottleneck in a way, kind of situations where you are in a bottleneck and then you push and you push and suddenly everything opens and you are excited, amazing. You start to develop again and things move fast forward, you know. But then suddenly, of course, you hit another bottleneck kind of situation. And again, you have to like try to struggle and figure out like how to make it work, or how to push through to go beyond that bottleneck again. Yeah. So I think that was something I was always looking at, you know, at CUDA to replace. I was always, in a way, looking at CUDA, let's say, as a sort of way to solve those kind of issues. But you see, then you end up with other issues. And this is the fun thing in the entire journey, is because you start with some assumptions, and then those assumptions, they work for a certain time, and then you hit other walls, let's say, other challenges. And then you have to figure out and you have to come up with a solution. And the reason why I like to explain this process is because I really want everyone to actually be careful how they are using tools. You're using the tools because there is a need for that tool, not because you're using for the sake of just using a tool. That's not the way we should do it. Yeah. So here, what happened is, this kind of analogy with bottlenecks. So what happened is, of course, I went through this kind of bottleneck of Java shaders. Still I'm not able to bring structural information or environmental information in, and then you go through that bottleneck, and suddenly now you're able to use CUDA and everything, it's great. But then, of course, other problems that arise from there is that CUDA and JCUDA, you have to write the code in a completely different way than you write a Java code. So you have to write it in a way for the GPU, and you have to structure your data the way the task in a way, in a very clear manner, to send correctly the data to the GPU. So there is a lot of work involved just in that, yeah, not in designing the actual system, like the agents to be more smart or so on. It's about, just programming the structure of the data that I'm going to send to these parts of the GPU and this CUDA cores and this CUDA cores, yeah. So just that, it's a lot of work, yeah. So what happened there, that I was like, there has to be another way. I cannot spend so much time just on writing the code to send to the GPU, because then in the end, what I'm doing here, I'm spending like hours and hours to figure out this and to make it work, just to have some simulations run very fast, and then I'm just using it maybe for half an hour, the simulation. So I'm wasting a lot of time on the other side then, So what happened there, during that time, I started to read a book called The Elements of Statistical Learning by Trevor Hasty. So I would highly recommend that book to everyone. If you want to start to go into AI, machine learning and stuff like that, The Elements of Statistical Learning, it's really a good start, yeah. So while I was reading that book, I started thinking of ways I could bring somehow statistical learning into agent-based systems. So what the idea was there was, how can I replace this kind of computational heavy tasks, like proximity calculations, let's say, with proximity prediction, in a way, models? Can I have, in a way, a sort of statistical model? And I'm calling it statistical because it wasn't really like per se, let's say, ML or deep neural networks, yeah. So this kind of statistical model that can give me, in a way, at least predictions about where some agents might be. So then I can have an agent that doesn't have to calculate the distance, can just assume or predict that it might be that there is an agent, and based on that, in a way, take certain decisions, So this was, I think, the very first part, or the start of my journey in ML and AI and stuff like that. Yeah, that was the intro, let's say. But it was an intro because there was a necessity for it. It wasn't because, as many like to use it as a sort of, right now it's fancy, it's trendy. So that's why I jump on AI. So of course, slowly my design interest grew even larger and larger, which is, I think, something normal. And it's where it's going to stop, I don't know where it's going to stop, but I think that's the great thing. You have to continually push yourself and continually try to grow and imagine even more and even more. And I think the amazing with this kind of bottlenecks is that every single time, once you pass one, you're actually thinking even more crazier than you did before. Yeah, you're like imagining even more, and it's almost like things are becoming even more complex. Yeah. So as my interest started to grow, yeah, I started to look into ML, deep neural networks, to see how you can start to design, to explore design possibilities, how you can explore the design space, how you can explore the design intentions, how can you augment creativity, and all these kind of topics. Yeah. So there I started to at that point I started to really engage with ML and with deep architecture, like deep neural networks and so on. Yeah. So like I said, I cannot really say that there was a moment where I realized that it's going to make a huge impact, as mostly my focus was, not necessarily on the technology, but on, the progress that I can make with this vision that I have about this kind of intelligence in architecture. So I think right now there are a lot of people that use tools just because, they are fancy to use. And I think we should use tools because of the problem that they are solving. or because of what they can add, or because they can add some improvements to the current methods that we are using. Yeah. So we should not use them as marketing tools. And I think this is happening like already. We are just at the beginning of AI in architecture, and I think already AI is used as a marketing tool. So we just put it in the name just to show that actually we do something great, when in fact we don't really do that many things, So I think, yeah, it happens that it becomes a buzzword, the same way that sustainable design and green design in a way became a buzzword. Many times, if you were to scrutinize like some projects that claim that they are sustainable, and you really dive into really the details, you start to realize that actually no, they are quite pretty conventional. They are not really sustainable. So probably also AI is getting used now as a buzzword. So we see this happening, yeah, like I said already. And if you are to look at many claims, you'll just realize that people that are claiming that they use machine learning and AI, they are mostly just using a k-mean clustering or a Disney, which of course they are algorithms from this huge class of ML algorithms. But that's not to say that suddenly now you're a ML, office, or you're working with ML, with machine learning, just because you're using a clustering algorithm, which is something pretty boring, let's say.
I see.
Okay, so that was a very large, let's say, answer.
Yeah, like there are so many insights in that answer, and like I'm observing that the AI hype has been transferring from like computer science, and now the architecture industry is very hyped about AI. One thing I'm interested was, so was that purely coincidental when like you had the problem of you wanted parallel computing for your simulation, and at the same time nvidia shared the api for cuda, and you thought, whoa, that's what I was looking for, and like and building upon that, like how do you stay up to date with so many development, because like there's so many research papers being published in computer science day by day, new technologies coming up. So
So I think the way I got introduced to CUDA was Shajay from Zaha Code gave a workshop in Studio Hadid. And I remember they were starting to work with CUDA, like just CUDA on Zaha Code, and they were using they're using that for Maya, and they were running this kind of process of relaxation, measure relaxations, and so on. Yeah? So that was when I got introduced to the idea of CUDA. I never heard of CUDA before that. Yeah. So the fact that I started to go into this kind of direction, it's kudos to Shajay, yeah, which is an amazing, amazing, amazing coder and also architect. So yeah, so I think I was a bit. It's not that you were lucky that exactly Dan could publish their API. It was just that, okay, probably it just happened that I was concerned with those questions exactly in that period. It was a coincidence, and it was amazing that I got introduced to that concept with Zahadi, with Shajay. Yeah. And I think that had to do then with to be in the right to be in the right place at the right time, or how is the expression. So I think if I would have been in a different university, probably I would never heard of CUDA. So that was a big important thing. And this is something that you were asking how you keep up with all these developments. So that's one way how you keep up. You have to surround yourself with people that are also crazy about technologies. And you yourself, you cannot keep up with everything, yeah, because my interest is in how I encode intelligence, let's say, yeah. But somebody else's interest, let's say Shajay's interest was how we make these processes faster, yeah, in the office. And suddenly, because you had interaction, you were in a medium where you had interaction with other individuals that had other interests different than yours, but suddenly you see how they're using certain technologies. Suddenly you're like, actually, I can use also that technology. Yeah. So I think that's the recipe And you'll see, personally, there is this kind of way of thinking, systems versus goals. Personally, I'm this kind of like system thinker instead of a goal thinker. Yeah. So there is this kind of ways of thinking. And what I mean by that is I can, let's say if I were a goal thinker, I'll say, I have to read all the papers that come out just to keep up to date, like to with all the latest developments. Yeah. And that will be a huge demand task. Yeah. Like something that, you don't have the time in the day to actually go through all the papers. Yeah. So then what other options do you have? So for me, it's like, okay, what if you develop a sort of system? What if you develop a sort of way how maybe that information can find you instead of you finding the information? Yeah. So what if you create a sort of network? If you create a sort of network of people that are quite interested in topics like this, like super advanced computational design or something, or other topics that you might be interested in. So that if you develop that network, then you're going to be constantly, exposed to what they themselves are searching and finding. Yeah. So that in case that, some interesting topic comes across that you find interesting, then maybe you're going to say, yes, I'm going to pick that. But I don't have to search for it. Yeah. It's going to be presented to me. So I think that's how you can manage them to keep up. Yeah. You have to try to develop a sort of system. You have to try to develop a sort of system that helps you in a way get more for less, let's say. Yeah. More
Yes,
information for less.
I think like that's a really great piece of advice, and I see a layer of intelligence deployed from virtual to reality, where like your network itself has like-minded people and supplementary skills, which all can work together to achieve excellence. Now we will move on to our next section, in which we'll get to know about Daniel's professional work and research work. So, Daniel, can you give us an overview about your work till date?
Right. So I think I also mentioned before. So right after graduating from Studio Hadid, I was hired as a computational design specialist in Blau, which is an internationally renowned architecture office led by Wolf Briggs. So over there, I really worked mostly on computational design strategies applied in design, and also design in different stages of design. Yeah, from schematic, conceptual design to also manufacturing, fabrication, and so on. Yeah, so we really developed like a lot of tools for optimizations for sure. We dealt with a lot of tools that improve architects, let's say, efficiency. So all those kind of like ideas we really covered, and we really developed those kind of things. So we developed a DPM Blau network that really help us to engage with creativity and really augment design creativity using in a way AI in that kind of way really allowed us to also revisit our workflows and see how we can augment our workflows. Yeah, because I think in AI there's a lot of discussion about AI automating or AI replacing things. Our view there is not really automation, it's not really replacement. Our view is mostly how can we augment designers' native abilities? How can we improve in a way the way that we design? Can we add like AI as a sort of assistant? So I'm designing something and I have an assistant that allows me to visualize the entire design space or something. Yeah. So those kind of things we are working with. Other projects that I'm currently working with is of course this project Gaudi and Gaudi plus neural networks. And in that project, mostly what I'm looking at is I'm looking at currently almost like the idea with AI is just throw as much data and the AI is going to learn. Yeah. And it's like, I think that's not really the way that humans learn. I think humans, we have a lot of processes of filtering data, you know, filtering like the type of information that we are going to learn and so on. So we have this kind of almost like a discriminator in a way function where we discriminate against relevant or irrelevant information. Yeah. So then in this project, what I'm looking at is how can you have a network that it's able to discriminate against this kind of like architectural, let's say, qualities that maybe they are not relevant. Yeah. and how can you just keep the ones that are relevant. Yeah, so that's the Gaudi plus neural networks. Of course, in the past, I also worked on agent-based parametric semiology project with Patrick Schumacher and a few other researchers. And over there, mostly we were dealing with this kind of idea of how space influences human behavior and how human behavior can influence space. Yeah. So we were trying in a way to create this kind of almost like generative model that can predict in a way a sort of spatial configuration based on types of social activity that's happening there. Yeah, so these are like a few like let's say keystones or key projects, let's say, over my now almost like 15 years almost of being an architect. So of course there are many other like projects early on in Copion Blau. I was, like I said, we were working with this kind of computationally designed tools, applying the design. So we were quite early on the parametric design also, and we designed a few projects with parametric design and was directly involved not only in the aspect of design like generation but also optimization phases. Yeah, so for example we had a small project, I think Martin Luther Church, or how it's called, Hamburg Church in Austria. Yeah? It's a very small like church. It's from Wolfprick's hometown, and we had this kind of like generative design kind of approach to the way that we design the building, and especially the roof at the top of the chapel. But afterwards, yeah, we also used tools of optimizations. Yeah, so it was very early. It was 2008, 2009, I believe. It was very early like instances of using this kind of parametric tools to engage in those kind of topics. So we had this kind of double curved surfaces, and the idea was how you optimize that surface so that you don't have that much area of double curved surfaces. Yeah, so that decreases the cost of construction, of manufacturing, and so on. So yeah, this is a small overview, then a few projects. Yeah.
I see. And if I were to give a very very high level of overview of grouping this work, is it right to say that it involves intelligent algorithms to generate new design, to do simulation, and to do optimization, like those three areas?
Yeah, so in some instances, yes, we were using something that I'll call, yeah, intelligent designs. In other instances, I would just say some algorithms were just a sort of rule-based design, yeah, which is just this kind of expert systems type of category. Yeah, we are not talking about learning systems. Yeah, lately we started to, I think since 2015, 16, when we start to deal more with machine learning, we start to bring topics of learning systems in. Yeah, so for example, we had recently a design for the central bank in Azerbaijan, and we had this kind of like facade that was twisting in a way, and the tower geometry was twisting in a way. So of course there you have, at certain design level stages, you have certain procedures that you apply. Yeah? So first you start by optimizing perhaps the design by having the least amount of double curved surfaces. Yeah. So you apply that kind of optimization, and that kind of optimization is not really something learning. You can do it with genetic algorithms or other parametric design tools. But then when you go into a phase of manufacturing and thinking about panels and how they are going to be manufactured, how you are going to transport them, how many families of panels you have, of course, you deal with so many variables that usually it's hard to have just a genetic algorithm trying to solve that problem. Yeah. So we started in that instance, we started to look at learning systems, and we start to deploy this kind of networks that were able to create for us families of different panels, different frames of panels, and so on. Yeah. So I think we ended up with something like 17 parameters, like from the way that the panel is curved and twisted, to angles, to lengths, and a lot of angles between parallel frames, and so on. So there are many parameters that those kind of networks actually helped us to manage sort of optimization. Yeah, but yeah.
I see. And can you walk us through one of your work in detail? Like, what was the approach? challenges faced, final output.
Okay, so probably I'm going to talk a bit about DPM-Blau. So DPM-Blau, I will say currently is the most advanced research that is dealing with the design potential of AI deep learning undertaken by any architecture office, any special big architecture offices. Yeah. So what deep learning does, deep learning explores this kind of potential of teaching machines to interpret, perceive, to create, to be creative, to propose new designs of buildings, and also augment design workflows or augment designer creativity. Yeah. So, so we all know that developments in AI mean in a way that computers can be trained on certain creativity criteria, let's say, to the degree to which AI can develop its own sense of creativity. It's still something that we can inquire and debate, let's say, but we can start or try to teach this kind of AI. So some questions that are very important for us is that can AI be taught without guidance how to create? Yeah, and of course here we talk about unsupervised networks. So for those that don't know, unsupervised process is mostly a process where the machine is just represented with a data set, and without any instruction, the machine is asked to learn the representation or the underlying representation of the data set. Yeah. Other kind of methods of supervised, for example, learning will mean that we have to create labels and specify exactly how the network and what the network learns. Yeah. So that will be a supervised process. Yeah. So we are looking at this kind of aspect. Yeah. Can AI actually learn without guidance? Yeah. In an unsupervised manner, can it learn the office architecture and style? And can it be, is it going to be able then to create or to propose new designs? Can that AI be taught to interpret things? Can it be trained or taught to reinterpret representations from one domain to another? Yeah, which is something similar that we as architects do all the time. Yeah, so we are always inspired by concepts outside of our architecture profession, and then somehow we translate those concepts into architecture. Now, of course, there are certain limitations here with AI. So currently, if you talk about visual concepts outside, then it's easy for AI to learn those things. But if you talk about actual concepts, like, you know, an idea, that's something that AIs, they have a problem with. Yeah. Or this kind of counterfactual in a way. If you have like counterfactuals, they're still something very hard for AI to learn. Yeah. So of course that we have to understand that teaching computers, it's to be creative, it's a complete different from the way that humans are creative. Yeah. But the problem with that is that we don't even ourselves, we don't know that much about our creative methodology. We don't understand yet the way that we are creative either. Yeah. So here I'm just giving a few some background, yeah, before I dive into exactly what we are trying to do. So we have to understand that our perceptions and our conscious visual representations of reality are not a direct mapping of the real world. Yeah. So what's happening most of the time, we are interpreting reality through certain filters based on past or present experiences. Yeah. So then you can say that those kind of experiences, they work as a sort of filter for us in the way that we are going to interpret the world and the way that we are going to understand the world. So you can easily say that, you know, our training as architects is then really working as a sort of filter. Yeah. So we are going to have a very biased, let's say, way of interpreting things. Yeah. So we as humans, of course, we have a problem at disentangling various semantic features. Yeah. It's very easy. Even the image behind me, this is an image created by DPM-Blau. It's very hard to disentangle in a way all the features, yeah, and to also make a sense of why the certain features are in a relation to other features in this manner or not. Yeah. But in the case of neural networks actually, they are very capable at that. Yeah. In special some classes of neural networks, yeah, they are very, very good at that. So then maybe we can use neural networks there. Yeah. So I'm saying this story again just because I mean, the reason why you use certain networks, there has to be a reason why you use that type of network. What's the problem that you're trying to solve? And what's the concept, the idea behind using these kind of networks and what you're trying to solve? And that's why I'm using this network, because it's going to help me do this, yeah? It's not because, I'm just doing it for the sake of doing it. So then all these things, in a way, there are a few like aspects, yeah, that these are limitations, yeah. A limitation of, as architect, you have a huge challenge to evaluate something because you have a clear bias. The way that you're trained as an architect act as a filter in a way, as a sort of bias in a way, the way that you interpret things, yeah. And then also you have an issue with disentangling, features. So can you use, in a way, AI to help you overpass these kind of limitations, let's say? Can you have an AI that looks at, let's say, at an object, a top perspective, like bird eye view, and still doesn't recognize that bird eye view as a bird eye view? You as a human, you're automatically biased, and you're always once you look down you're looking down at an object, you already, in your mind, you already know that I'm looking down. Yeah, it's a top down, a perspective in a way. Yeah, so you're going to perceive the composition in that kind of manner. Yeah, while on AI, you can easily say, no, we can remove that kind of filter. Yeah, we can ask a network to look at something with completely new eyes in a way. Yeah, so that can help you then, in a way, understand certain compositions differently. Yeah, and it can go over then, or can overpass these kind of limitations. And then the same happens with semantic features. So what we are interested in there, we are interested in this kind of topics of, can we as designers go inside design and just affect a few parameters, let's say, of design, and then have that updating in a way, but not in a parametric sense, yeah? In a sense of, like semantic and features, yeah? Can I just go in and, let's say, I like the kind of result, but I just want to affect, let's say, a lower level of this result. I want to just affect the structure of it. And when I'm saying structure, I mean composition, yeah? I just want to affect the composition of it. I don't want to affect the level of details and patterns and stuff like that. I just want to affect the composition, yeah? Can I affect that composition while still retaining all the other relations with the upper like levels, yeah? So what I'm talking about here is that, it's almost like this kind of idea of, let's say, in recognizing objects, let's say, is that kind of saying, it's a bird, no, it's a plane, no, it's Superman, yeah? So it's almost like this kind of levels of perceiving things, yeah? So you're just looking towards the sky, and you just first, probably you just see an object, yeah? You haven't identified yet the object. But then you continue in a way, it's almost like you increase your resolution of perception, and suddenly it looks like a bird, yeah? So it's not just an object now, it's also looks like a bird, yeah? But then you increase even more your resolution when it comes to perception, and you realize, well, it looks like a plane now, and you increase even more, and you realize, well, now it's Superman, yeah? So in the same sense, in a way, you have these kind of levels of resolution that describe or encode different information, yeah? So for us, then, this is something that could be interesting. Like, can we affect those levels of design? Can we intervene somehow at a specific level and just affect that specific level while having all the other levels, in a way, still retaining their relationships, yeah? So like that will allow, in a way, designers to really engage with design in a completely new way, yeah? It's going to be something unique, and it's really going to be something like, we are talking about augmentation, we are talking about, an assistant AI that really helps you explore your design ideas, yeah? So how we do that is, it's a very complex process, and many aspects of this I cannot really disclose, because it's a private office. We are not really going to share the network publicly, but it's very challenging because Kubhimblau as a style, as a architectural style, is not something that is very homogeneous. It's something that has like it has a very wide range, yeah? Kubhimblau has a very wide range of projects, yeah, in terms of stylistics, yeah? And because of that, in a way, you have to create the network in a certain way that it's able to still grasp, in a way, those kind of very wide domains, let's say. Because if you have a network that has, let's say, a very well represented data and it's very homogeneous, it's relatively easy for the network to learn. But if you have this kind of very sparse, in a way, data, very wide, then it's a bit more challenging. And you have to develop like different filters or different kind of methods of how the network actually learns to actually get somewhere. And we do this like right now it's mostly just design, but we have multiple levels where we really try to apply in the design process, we try to apply this kind of strategies. So this is mostly like conceptual design, let's say, but then we have phases where we talk mostly just about processes, how we augment certain processes. How do we speed up certain things? And of course, those are mostly almost automation kind of tasks. So all this kind of the Deep Hemoglobin project, it's a project that is not only visual, but also has also some very, very pragmatic, in a way, topics that it's addressing. The visual probably is the PR side of it, let's say, but the other parts like are really parts that are really going to have a direct impact on the way that architects are going to work in the office, and how fast, in a way, or how what the quality of level information that they are going to get, let's say, in the process, in the design process.
I see. And I really like the example how you explain the layer of perception. One thing I wanted to clarify is like I have experimented with StyleGAN model, and one can create cool latent walk videos. And when we do like learn features interpretation, you change one parameter. I think it gives it gives entangled features where you change one parameter. It will also change structure and fabric. So one might need to do additional layer of disentanglement to divide those features, and then manipulating one dimension of that vector, it only changes one feature.
Yeah, so I think we have to go beyond that. I mean, StyleGAN, yes, they provide some great algorithms and some great method of exploring. But for us as architects, we have to somehow identify the features. We cannot just blindly just move a few sliders and recognize that those are the features. So then you have to run like other algorithms that are able to extract the features. And for example, that could be a PCA. Principal component analysis. So you can have a PCA that actually tries to identify the features, and then once you have the features, then you can say, okay, just this specific feature I'm altering. Because the StyleGAN, it's space of exploration, but it's very, I'll say it's very, very broad, very vague in a way. It's not something extremely specific, at least the type of methods that come with the algorithm, with the StyleGAN algorithm.
I see. And I have seen that you have like taught workshops on pix to pix and other GAN models. Just a question on that side. Are there any like lessons learned or like tips you want to share about curating the data set? Because let's say if one wants to make a style GAN of architecture buildings, but if in the data set there are trees, like it will also learn to create those trees and background elements. So any tips on how, if there is an intent, any data set curation strategy?
Okay, so with data, it's also this topic of bias in a way. So, and these are a few challenges that we will have to address for sure. So whatever you put in the data, that's what the network is learning. It's not going to be able to distinguish between buildings and trees or other kind of elements. So because of that, in a way, you have to be very careful, and you really have to know what you're after, what you're trying to actually ask the network to learn. So another thing here is, so you have to be very, very careful with that, like data set, like the type of information you have in, and to have that represented correctly. If you don't have access to math skills of going in and altering the StyleGAN algorithm, then you really have to be aware that it's all about the data set then, because if you don't have a way to change the way that the network learns, then it's whatever you give to the network is going to learn. So that makes it very, very imperative, like data set. So here, when it comes to StyleGAN, it's also not only a question of, what is represented in those images, but also the quality of the images, yeah. And also the consistency of that quality, yeah. Because what's happening is you're going to input, let's say, images that are very pixelated. And because of the pixelation, certain features are described that actually don't exist or they are not relevantly designed. And then suddenly you're in a way making that network to train that way, yeah, which is not really something that you want to have, yeah. So I think this discussion. I know that some architects they prefer to play with this kind of bias in data, and they are like, they are just saying, like bias can give us something interesting, and we are going to overfit the networks, and we are going to get something interesting by overfitting. But then for me, it's like, why do you use AI then? AI is not about overfitting. It's not about memorizing. AI, it's about learning. So why do you need AI if you have to overfit things? So what we mean by overfitting things is it's almost like the network is memorizing the data set. It's not learning it. It's just memorizing it. Yeah. And here it's also like this kind of question that many try to answer for a long time, yeah. And also Alan Turing, for example, tried to measure intelligence and see if a machine is intelligent and so on. But yeah, he didn't actually define what intelligence is in that test, yeah. And then also we have this kind of philosophical discussion in AI about Chinese room, which is pointing to the fact that, it's pointing to the fact that, you can just because you know to translate Chinese by looking at the dictionary and a set of rules, that doesn't mean that you know Chinese, yeah? So the same then happens also here with overfitting with networks. It's like, just because network overfits, then doesn't mean that then the network learned, yeah? That's not really an AI. So AI experts, they are going to tell you that we are not using rules anymore, yeah? And that's why these kind of AIs, they are not expert systems, they are learning systems in a way, yeah? So that's why they are saying, we are not using rules anymore. We are using deep architectures, which are learning. Yeah, they are these kind of architectures that are learning. So we are fitting a model millions of samples, and then in this process there are no rules somehow implied. But once you have overfitting, then what exactly is that? Because that's not learning, yeah. That's not learning, that's memorizing. That's almost like you figure out the rules, and just based on the rules you are defining certain things, yeah. So here I think we really have to be extremely careful, yeah, with the data sets, and also of course with the training of the networks. Because why to use AI if you just memorize? You don't need AI for memorization. So what was the question again? It was about data sets. Yeah, data sets, tips about data sets. Yeah. So this will be a few tips. Yeah, and also try to understand like the data set topology. Like you're dealing with a data set that is very very homogeneous. Are you dealing with a data set that has specific clusters in a way? Or what kind of data set you're dealing with, yeah? And based on that, then you can maybe augment differently your data set, yeah? That's a different topic, yeah? For example, if you have a machine, an object detection, let's say, kind of algorithm, that you have a machine that tries to detect a chair, let's say. So a chair is a chair even if the chair is sideways or upside down, yeah? So then if you go with that kind of idea and you understand what the task that you're applying or what the task that you're asking the network to learn, then you can say, okay, I can augment the data set. So instead of just having chairs that are normally placed, I can also flip them, yeah? Because that flipped chair is still a chair, and the task is to detect or to identify objects, yeah, as a chair. If the task will be different, then probably that will not apply, that those kind of like augmentation techniques, yeah? So here you have to be careful and with your data set, like which is exactly the type of task that you're trying to ask the network to perform. And based on that, you're augmenting the data. If you're trying to generate buildings, for example, and you have a lot of samples of images of buildings, and you don't want to go in this kind of very speculative direction where you say buildings are upside down or something, then of course you cannot flip images upside down, yeah, because then the skies are going to be down and the buildings up, yeah. So there are different, way, techniques that you can apply in a data set, but you always have to be aware which is the task that I'm trying to solve. Yeah. And based on that, then you take these kind of decisions of eliminating in a way information that is irrelevant, augmenting data set, or understanding the structure of the data set, yeah, the topology of it.
I see. And moving on, like just to be like no a specific, let's say problem. Let's say someone wants to develop a brutalist architectural style generator tool, and just for example sake, they want to use StyleGAN. So, and they want to make a creative brutalist style which the world has never seen before. So one approach could be they can have, let's say, 2000 images of past brutalist style, train it, and in order to have some creative mashup, they can also add some brutalist artwork image, or they can go totally crazy and add classical architecture to see how it will turn out. So like I couldn't find any framework that okay, if we want a creative style plus novelness, like what data should be added.
So I think there we have to understand a few things, and I think describe types of creativity in a very very good way. Of course, there are other like types of creativity that are described by Margaret Boden, which is another great AI researcher. But I'll just use his in a way Demis Hassabis explanation of types of creativity. It's a sort of definition or sort of categories of types of creativity that deal directly in a way with machine creativity, not so much a very broad statement like in the case of Margaret Boden. So in his case, he's saying that we have three types of creativities. Yeah, so we have interpolations, we have extrapolations, and we have true innovation. So in the case of interpolation, what you do, most of the neural networks, they are very good at that. Yeah, they are very good at synthesizing data and then interpolating data. Yeah, because you can think of this as, you know, AI networks. They are these kind of huge statistical machines. Yeah, they are able to average and find patterns in data in a way. So what you can imagine is that if you have a StyleGAN like you were describing, yeah, so you're saying, okay, I'm going to give brutalist examples of brutalist architecture and also paintings and also art or something like sculptures or something, yeah. And I'm doing that with the hope that by doing so, I'm going to end up with a completely novel, in a way, kind of result. Yeah. So what you do actually there, you're creating a sort of design space where you're saying, I have paintings, brutalist paintings, I have architecture, and I have, let's say, sculptures. So you're defining in a way points in this design space, yeah, defined by that brutalist in a way style, yeah. And then what you're asking the network to do is just to learn the representation. So what the network will do will learn the representation, and once it's able to learn the representation, would say, I have a brutalist building, I have a brutalist painting, and I'm going to create averages, let's say, between, yeah. And suddenly that average, yeah, of course, we can say that it's something completely novel, of course, but it's something novel within that specific domain, yeah. It's not something outside of that domain, yeah. So then is it really learning? Yes, probably it's a type of learning. It's a type of creativity. Yeah? We, as humans, we do very, very much so. In many instances, we do very similar things. Yeah. So that's one type of creativity then, yeah. Like we can say it's interpolation. It's just, the ability to really synthesize something and really interpolate between, different options. But then you have also the other type, which is extrapolation type of creativity, defined at least by Demis Hassabis. So in that case, what you have is you have an AI that outputs for you something outside of the domain, yeah, outside of the domain that we define, yeah. So that will be something that it's considered sort of extrapolation. It's a higher level, let's say, of creativity, where it's not only that you output what you give to the network, but you output something that's completely new outside of the domain described in the data set. Yeah. So personally, I'll make an argument that CycleGAN is more capable at extrapolating than the StyleGAN. A StyleGAN is perfect at interpolation. It's perfect at learning the representation of something and then really know how to interpolate and create all these kind of latent walks and so on. Yeah. A CycleGAN, on the other hand, allows you to have more different domains, yeah, and allows you to translate from one domain to another. And the cool thing about StyleGAN is that you don't end up in the end with results that are representative necessarily of the one of the domains. They resemble some features, but they are not exactly the same domain, because they might have a different structure from the first domain and a different stylistic from the second domain, And suddenly you can say that, okay, that probably is a sort of interpolation, it's a sort of extrapolation that is more creative than the interpolation, And then you have, of course, the other one is the innovation part, which is something that, you're almost like outside the box, outside of even the experiment, which is something that we don't really have now, So that's how I'll describe those things, And we have to understand then, what we are trying to do, Yes, I'm trying to create something novel by combining, mixing paintings and architecture and sculpture for brutalist style, but in the end, I'm still just within the domain of brutalist architecture,
I think like that was a really good explanation, like with examples and the framework.
Mhm.
It makes a lot of sense. And like I was like watching the documentary of AlphaGo, and like they were using reinforcement learning algorithm, and there were some creative moves. So do you think like that can be an algorithm for getting totally innovative move?
So AlphaGo, yes, I'll classify it as a sort of extrapolation kind of creativity. But in that case, it wasn't just reinforcement. I think they had two networks, that they used. Yeah, they used two networks that one was, I think, evaluating, the other one was trying to predict or something like that. So in that kind of way, the algorithm actually became creative, let's say. So reinforcement learning, yes, it's something probably allows for more this kind of extrapolation kind of creativity. I remember very early examples of reinforcement learning. They had this, I think at MIT, they had this kind of simulation that they were trying to train a AI bot to learn to walk. And what happened is that at one point that robot flipped upside down, and it figured out that if I'm just going with my elbows, I can walk also like this, And it's funny because we were trying, or researchers were trying to teach that AI bot to walk normally, like on your feet or something, and then the AI somehow figure out the smart way to, I can use my elbows actually to walk, upside down. So probably reinforcement learning probably allows for more room for this kind of like more creative moments to happen than this kind of supervised and unsupervised.
Moving on, according to you, what are some roadblocks faced by AEC industry to adopt AI?
Okay, so this is a big topic. So, okay, let's try to address this not only from a design perspective, let's try to address it like overall, because I see that always when somebody is asking an architect about AEC, the architect is talking about design in architecture, not about engineering and construction. So I think the AEC industry is really facing a huge, significant, and persistent, in a way, hurdles, both internally and externally to the industry, such as industry fragmentation, the difficulty to recruit talent, and also this kind of like not efficient collaboration and knowledge transfers. So I think we have to look at, we cannot like just isolate AI and say how AI, which are the challenges for AI, because I think AI depends on multiple other technologies, like for example big data and stuff like that. AI without data is nothing. It's just a fancy tool, but if you don't have data for it, it's irrelevant. So I think because of that, we have to look at all the other technologies as a whole and their potential on the industry. So I believe that technological advancements offer, let's say, a very tremendous potential to tackle some of the challenges, that we have. Like I was mentioning, like industry fragmentation, transfer knowledge, and so on. So we have to. I mean, all these kind of technologies, let's say, machine learning, deep learning, computer vision, big data analytics, BIM, 3D scanning, UAVs, blockchain, there are many, many, many technologies that could have a great impact. And I think sometimes these kind of amazing breakthroughs in the industry happen when you have a convergence of multiple technologies. It's not always just one technology. Yeah? So we can have for sure sort of, let's try to understand from that perspective of data. Yeah? So we can say that soon every single architecture element is going to be associated with data streaming or data gathering technology. Yeah? Everything from thermostats to doors is going to be connected to the internet and is going to broadcast its use. Yeah. So here we can make a very valid point that with more access to data, then architects suddenly they are going to be able to improve more their design, to design safer, to design more efficient, to design more unique buildings. Yeah. And that's also the case. And personally, I'm also fascinated about that thing. Yeah. So once you have this kind of data gathering technology for every single architecture element, we are really going to be able to predict how our buildings are performing. Yeah. But at the same time, what's happening is that clients are starting to ask architects to deliver more than just drawings. In many instances, yeah, the clients are also asking for the BIM information in order to use for supply data for downstream applications like facility management. Yeah. So these developments then will mean that captivating visualizations in architecture soon will not be enough to sell a project. Yeah. I think architecture offices, they will have to show that they can back up their predictions with real data. If you say that the space is going to be used in this way, you'll have to prove it with data that the space is going to be used that way. So we might start to see, in the future, this kind of, I think they are called performance-based contracts, where a portion of architect's fee is going to be withheld until past occupancy data is validating the prescribed design performance. Yeah. Which is something I think for many architects is scary. Yeah. So we are going now from challenges of AI in AC to actually the implications of AI in AC. Yeah. AAC. Okay. So I think other roadblocks for sure is this kind of PR stance that personally I don't really like. And the reason why I think those are roadblocks, because they are going to lead to architects becoming complacent in a way. And real progress in this area is not going to materialize because of that. Yeah, people are just going to hide behind, we are using ML, and they are going to just take that kind of dopamine hit and that kind of publicity that comes with that, and then no further progress will be done there. Yeah, because as long as the publicity still goes, why should we bother to push very hard? Yeah, and I think that will really hurt in a way the industry, because we are just going to create this kind of fake illusion that actually things are progressing when in fact they are not really progressing. Yeah, we don't have like really super involved like parties that are developing these kind of tools. Yeah, for the industry. Then, of course, the another roadblock is the lack of unifying standard of describing building information. That makes it very difficult for AI tools to be implemented. Yeah. I understand that there is a BIM modeling, but even BIM modeling, it's used differently in different offices. So it's very hard to say that I'm collecting data from multiple offices, because that data has different format or different structure or something. Yeah. And then also another aspect probably is also the lack of user-friendly interfaces. Yeah. So I think it happened the same also with computational design. We expect some of our architects to become geeks, and it never materializes. Yeah, we say Grasshopper, it's easy to use, and usually you just have like a very tiny fraction in an architecture office that actually deals with parametric design. Yeah, the rest, most of them, they are just modeling or drafting. Yeah, so I think the same kind of thing is going to happen with AI. We cannot expect architecture offices just to implement, because like it happened with computational design, AI is even more complex than that. So right now, for example, in Curation, we are working exactly on this aspect of Deep Blau is extremely complex as a network. And many times, even for me to try to explain it to other peers, how exactly the network works, it's quite a complex task, yeah. But imagine that, to ask a designer in the office to figure out a way to deal with deep blau. So we really have to create like interface for that. So we already start to build up in a way an interface that makes it extremely friendly for designers to interact with this in a very like, you don't have to know like, a lot of things about AI. You just have to go through the protocols, a few like, buttons, a few options, and those options in a way they trigger different protocols in the network, yeah. So you're using it for design space exploration, or you're using it for translations from one domain to another, or what you're using for, and then automatically you get those kind of results. So I think this will be something imperative, this kind of lack of user friendly. I think that's also another roadblock that for sure it's going to affect things.
And like I like the fact when you mentioned about like how architects might require to justify, because ultimately in one form like AI models is are based of prediction. They're predicting at the end of that model. So maybe like architects can not only study the data but also using that as a framework to propose design and justify AI that okay it really works. It
Yeah, so that's a very complex discussion, personally, I believe, because it's like, yes, AI it's predicting, but we have to think like what exactly AI is predicting, like, and again, going back to the discussion of data sets, we have to really understand that what we are doing, we are encoding our own biases in the networks, yeah. I know that people are talking about bias, and the network is biased, but the network is biased only because we as humans, we are biased, not because the network has a issue. So we must understand that, let's say, if a structure was prevalent in history, and or a way of thinking was prevalent in history, and we ask an AI to learn a data set that is defined by that, yeah, AI is going to create something that it's biased, similar with that kind of like the prevalent, let's say, structure, yeah. So, for example, let's say that you're trying to fix a thing, yeah, like, or you're trying to look at the structure of companies. And of course, in the past, most of the companies, they had like, let's say, a male leadership, yeah. And right now, if you come and more recently, we start to see more also female leadership. So if you take then all that data set and you ask an AI to learn that information, AI is going to really give, let's say, preference to male kind of leadership than female leadership. And only because you have more examples of male leadership than female leadership, yeah? And then suddenly what you understand here is that actually you're encoding that kind of bad information into the network, yeah. And that's why personally I believe, that the way that we are training the networks probably is not really the best, because we as humans, we don't operate that way. So then we also can think about this idea of utility, yeah. Like, it's very prevalent in the human history, and it's this kind of idea that what is good for the public is good or ethical, yeah. Of course, in a way, that idea can be abused, yeah. And the same also, I think, in architecture, we can have the same kind of issue. It's like, you have data sets generating some spaces, we consider them that they are good, but because why they are good, So I think we really have to be very careful with this, yeah. AI is going to predict, yeah, we'll have to predict in a way that the spaces are really used the way that they're used, but then there has to be also room for how people are going to evolve and how people are going to use differently their spaces, because that's going to happen for sure. And your AI models are going to be trained on past data, and it's not going to encode in a way the new data. And the problem with that is this: you have past data that spans, let's say, 50 years, and you have new data, or let's say in the last 10 years, a different way of inhabiting spaces emerged. Yeah. So now you have 50 years with 10 years. The network is just going to give you again, the dominant, the prevalent, in a way, preference, which is, the past 50 years, So I think here it's a huge like concern, and we'll have to see how that works.
Yeah, like I really hope that the people who are deploying these algorithms are not just doing like surface level output, but also going deeper into, wait, there are a lot of implications with the data set, with the intent and with the prediction. So I
Yeah,
should be very careful.
definitely. Yeah.
Okay. Uh, the next question I have is, according to you, what are some applications, tools, or techniques in AC which would be common 5 years from now, but not widely used today?
5 years from now. So yeah, I can just take a try at it. I mean, right now, AAC industry is, I think, one of the largest industries in US. And I think it has over like a trillion, or it's making $1 trillion each year or something like that. Yeah. But what we have, problems that we have is that 98% of all these incur costs, overruns, and delays because of lack of proper visualization, let's say, capabilities to recognize issues or design conflicts on the site. Lack of communication, for example, for different construction parties, and also lack of support for advanced communication technologies. Yeah. So I think some technologies that are going to be present in the following years, of course, AI and also generative design will have a great impact on improving quality of design, lowering costs, perhaps reducing risk, and so on. Yeah. And also, it's going to probably AI is going to be also used in construction-based management, like safety, quality management, and contract management, and also probably like during the design phase, like checking up if you're up to code with certain designs that you're proposing. Yeah. I think other than aspects of this or other technologies, when it comes to collaborations and contracts, which are very often very challenging, I think blockchain technology might help there to improve essential aspects such as trust in multi-party, let's say, collaboration and contract enforcement. Then also when it comes to increasing information transmission efficiency, probably AR and VR are going to be very useful for construction management, as they can improve this kind of communication among different parties and provide better visualization for engineers, let's say, and designers. Yeah. So, I mean, this AR technologies, for example, they could be used for safety training, safety management, progress tracking, labor management, defect management, energy saving. I mean, there are a lot of like uses there. Yeah. So I think these kind of technologies, I think they are going to be very much used in the next years. Yeah. Sorry.
I see. And like I'm also noticing a big trend of like computer vision technologies used in like solving, let's say, safety compliance or many other problems outside the design aspect of AC.
Yeah,
See,
so for sure. I mean, that's where the push is going to come. Yeah, because I think we have to understand, if we're architects as designers, we have to understand that still it's a money game. Yeah, if it doesn't make sense in a way to apply this kind of technologies, and if these technologies don't bring something new and a better way, then no one is going to use them in the industry. I mean, and it's making sense. It's like, why will they use them if they are not improving the process? You're just overcomplicating the process. Yeah. And I think this is, again, going back to my argument, like we have to use things because they are the correct answer to certain problems. We should not use them only because it would be great for architecture industry to have AI in. Yeah. If we don't solve problems with AI, then better not use it. It's just going to overcomplicate the process otherwise.
yeah. And like part of it also, I feel like because of the social media, a lot of visualization has been fantasized, like try different tools, make some cool visualization.
Mhm.
So a lot of times, like in students or young professionals, the thinking of problem solving and then discovering the right tool to solve it is lacking, rather than just use different tools.
Yeah, so just to pick on that, is you have to understand that suddenly with AI, as an individual, suddenly with AI, you really have the option to make a big impact on the world that you're living in. Yeah. So if you use AI just for the sake of it, like just having fun and explorations, that's great. Yeah, I think there is a place for that too. But then if we talk about application in architecture, then we have to think about how we make things better. Yeah. So over the next 30 years, I think we are going to build more building that we ever built before. And to do so, then we have to find like extremely smart ways of building, because just imagine the demand, yeah, to build that much, and the implications that that kind of demand has on the surrounding, yeah, like uh, natural world, let's say, yeah. So how we are going to design that, we cannot then design just fancy buildings, or at least fancy experiments are not going to help us solve that problem, yeah. The idea is that you still want to create like high quality architecture, and also from a design perspective high quality, while at the same time you have also these concerns addressed, yeah. So you can spend your time in a way on developing AI tools and strategies that really have a huge impact on the world. Yeah, it's up to you in the end. Then, yeah, if you want to solve and address those problems directly.
I see. And the last question in this section is, what are some emerging trends in the field of AI which architects should keep an eye on?
Okay, so I think all this idea of what I was saying, before with this aspect of everything is going to stream data. Everything is going to be associated with data gathering technology. So that aspect, in a way, it's something that I think is going to revolutionize the way that we are going to design, for sure. Yeah, because like we discussed previously, it's going to have implication of, you have to prove that your design somehow it's really doing what it's doing, because most of the time as architects we work with assumptions. Yeah, we are just making assumption that if we design this way based on our previous experience, let's say, we design this way, so the people are going to use the space in this way. Yeah. So I think these kind of trends of, having everything streaming data are going to have a huge impact. And then of course, like that coupled with AI, that is going to give us in a way all that kind of information and that kind of statistics about how spaces are used. I think those are going to have dramatic influence on AI. And I think AI's architects, they better catch up with that, because otherwise they are really going to be left behind, and probably somebody else is going to take their job. And I'm not talking here about job replacement, but even currently there are 80%, or if maybe even more than 80% of architecture is not designed by architects. So I think if architects are not going to step up to this, then other parties out there are going to be willing to say to a client, to say, we are going to provide the service for you. Yeah, we are going to take away this responsibility to show you that what we are offering you as a design product also is going to perform in this way. Yeah. So I think if architects are not getting there, they are just going to be replaced by other professionals from maybe real estate development, or who knows what other real estate industry kind of people are there.
I see. Yeah, like even like a few outside AEC companies like WeWork or Sidework Labs, like they're also trying to develop technology. So if we don't, anyone else will.
Yeah, for
Like,
sure. And these companies, they'll have a stronger power than to say how to design, yeah, than we have. So then we lose a lot of ground, yeah, if we don't engage with this.
I see. And also, like I think a lot of progress I believe happened in computer science industry is also sharing code, open data set that facilitates even the young people to experiment with that code. I hope the industry starts adopting the sharing of database.
Yeah.
So it's challenging.
Yeah. So I think once we move to more AIs that are not so heavily dependent on huge data sets, maybe then that will be something positive for architecture. Yeah. Because that will not require, in a way, this kind of sharing of knowledge that should be like very widespread, let's say. Could be like that you have limited like a share of knowledge and still have an AI that really helps you there. So probably probably that is going to go hand in hand with the progress on the neural networks too.
I see. Lastly, we'll move on to our final section, which is advice to students and professionals. So, Daniel, what will be your advice to students who are interested to do similar work?
So you have to love it first, yeah. So that's the first thing, yeah. Don't jump in it just because it's trendy, or that because everyone is doing it, yeah. You really have to love it, because it's going to be something extremely demanding. And here, when we are asking like students and young professionals, we are assuming that we are referring to architects, yeah. Architect students and architect professionals, yeah, architecture professionals. So in that instance, you have to understand that you don't have computation, you don't have computer science background. So that's why I'm saying you have to love it. You have to really be passionate about this topic in order for you to be able to go through all the upside downs that comes with this, yeah. Because it's going to be a lot of like extremely steep learning curves that you just realize that finally I arrived somewhere, yeah, and you're enjoying that you arrived, and then suddenly you realize that there is another super steep curve, a learning curve that comes, yeah. You have to be willing in a way to put in that kind of effort to constantly in a way learn, and yeah, and put in the time, because it's going to take a lot of time. I know that might argue that you have to go with 5 to 6, or how is it, the program, or 6 to 5. But if you want to get somewhere with this kind of technologies, you'll have to put a lot of time. Yeah, you'll have to dedicate a lot of your time to really get there. Then, of course, another thing that I would advise is similar with what we talked already about. Yeah, when it comes to try to create a sort of network for yourself. Yeah, like you're interested in going into this kind of ML, start to go around these kind of circles of people that really deal with those kind of topics. Yeah, you have to engage with the type of people that work on those kind of topics. Yeah, so they don't have to be like the most advanced ones, but you have to make your way to the most advanced ones. Yeah, start surround yourself with people that really are into computation and really in a way address these kind of topics. Yeah, and that will really help you in a way then to will help you in a way navigate the field, because there are so many things. Yeah, so many things. Like right now we barely touch on something, and just look at us. Yeah, we are going almost for 2 hours or 1 hour and a half now, and we barely touch on certain things, and there are so many other things out there. Yeah, we just touched on deep on supervised, unsupervised a bit, and reinforced learning, but those are just we are just barely scratching the surface. So because of that, in a way, you need people around you to help you navigate this field, and help you in a way get this kind of knowledge faster, to understand and to take decisions faster. Yeah. So other advice will be start learning to code, because this is going to be something extremely crucial in the future. So you can start most if you are interested in the machine learning and AI. I'll say most of the code is in Python. So I'll say try to start learning Python. Yeah, you don't have to be extremely advanced. Yeah, you can start maybe just basics, understand Python, and maybe that basic understanding of Python will allow you at least to start to engage with certain networks. Yeah, and to know how to operate them and how to start training networks and so on. Yeah, and then later you can increase slowly your knowledge of Python. But here I'll say this has to be a daily effort in a way. You really have to be very committed to this, because things are changing by day. And for example, you're trying to write a book today, let's say, and you have a feeling that you're ahead of everyone, and by the time the book is out, it might be that the book it's outdated, because of the speed of progress that's happening in this field. Yeah. So yeah, just be aware of these aspects.
I see. And yeah, it's important that, like you mentioned, interest and time commitment, because like few of the things you mentioned, like parallel computing or different algorithms, there are like like specializations in computer science just to study that topic in detail. So it definitely requires more time to understand those stuff from non-CS backgrounds.
Definitely, yeah, definitely.
Any books, conference, or courses you would recommend to people?
So personally, I have three main books that I start with. Yeah. So the one was the Elements of Statistical Learning. So that was my first, let's say, introduction to this idea of statistical learning. That also then leads into machine learning. Then there's another book called the 100-page machine learning book that I'll really advise everyone to go over. And then, of course, the other level will be deep learning by Jan Goodfellow. So as you can see, it's like, so first is statistical learning, just to understand in a way those kind of concepts of statistics and so on. And of course, that's quite a big book. It's about 300 pages or something like that, if not more than that. And then you have the 100-page of machine learning. Yeah. So once you have the introduction, let's say, and you kind of understand statistical learning and those kind of ideas, it's easy then to grasp certain ideas of machine learning because they are they are based on statistical learning. Yeah. And then once you have that part, it's also easy to go into deep learning because, deep learning has a lot of techniques from machine learning and statistical learning. So I'll approach it probably something like that.
I see. And
But there's also a Stanford course on AI that it's online, I think, so you can easily take that.
yeah, like CS 229, 231. It's
Yes, I
also on
think so.
YouTube. Yeah, yeah, yeah.
Yeah.
And just to dig deeper, so I have seen like this time in Acadia, there were a lot of papers and couple of sections focused on machine learning and architecture. Are there any like workshop or conference apart from that which people can attend?
So I think also in special for architects, I think international conference or on computational creativity, I think it's also a good conference to be part in. And that's mostly because, you're dealing with the aspects of creativity in this kind of creative fields. Yeah. So that's, I think, a good conference to be in. Of course, there are multiple other, like in architecture, like SIM AUD and Kadria and all those. But yeah, I think AI in architecture will not allow you anymore to stick just with architecture. AI in architecture will force you to go interdisciplinary, and you'll have to, in a way, start to engage with other conferences, not only architectural conferences. Yeah. So that's why I was mentioning, ICCC, which is International Conference for Computational Creativity or something like that.
Yeah, I think it's like some maths or stats conference, some AI, some
Yeah.
architectures. Even in gaming industry, it's picking up. So so the last question of this interview is, how can our listeners follow you and your work?
Okay. So my work mostly, I have a website, but sometimes it takes me time to update to keep it up to date. So you can get in contact with my work on nonstandardstudio.com. You also can find me on Facebook as Daniel Bolojan. You can find me on Instagram as Nonstandardstudio. You can find me on Twitter as Nonstandardstudio and also as Daniel Bolojan. And also you can find me on Clubhouse, the latest amazing app. Yeah. So on Clubhouse, I'm also like hosting weekly meetings in a way that deal with AI, computation, and architecture. So feel free to join if you want. So I'm going to have those kind of meetings usually on Sundays from 6 p.m. Eastern time.
I'll definitely join the next meeting.
Amazing.
Uh, so thanks a lot, Daniel, for this amazing interview. I had a great time.
Amazing. Yeah, thank you. I think it was great. It was a very interesting discussion. And as you might already see by now, like there are so many topics to go in. I think we steered away from a lot of questions because there are so many like things that we could have talked about. Yeah. So yeah, thank you. I really enjoyed this. Thank you.
I see.